Thank you. Yeah, today I'm going to talk about the experience we have gained through two citizen science projects that we have carried out here in, at our museum in the last years. First, I have a slide, and I'll say a few words about what citizen science is. And according to the European Commission, Directorate General for Research and Innovation, it's formulated that citizen science is the voluntary participation of non-professional scientists in research and innovation at different stages of the process and at different levels of engagement, from shaping research agendas and policies to gathering, processing, and analyzing data and assessing the outcomes of research. Furthermore, they stress that within EU's research collaboration, citizen science is emphasized as important both for the impact of research on society and for the public trust in research, which is very important, especially these days. The importance of citizen science is further emphasized since it's one of 8 pillars of the European Commission's open science policy. As I said, we have carried out 2 different citizen science projects. The first, which is the Klæby project, was organized in that way that we, as experts, interpreted LiDAR datasets in that municipality, and then we used volunteers from the historical society to help us to do the field verifications. On the other hand, the Meråker project, Meråker is also a municipality. We flipped the coin and we let non-professional volunteers interpret a LiDAR dataset, and then we as experts went out in the forest and checked the anomalies, did the field verification. So the field verifications was done by archaeologists. Yes. According to Hackley, citizen science can be divided into 4 different levels. The lower levels is quite straightforward. It is about crowdsourcing. You can use citizens as sensors, for instance, put a GPS in the rucksack of people that is walking in the terrain, and then you can download the data afterwards. Level 2 is a bit more advanced because the volunteers is involved in the interpretation of the data, or can be. And then level 3, it's even more advanced because you involve lay people to get involved in problem definition to form the whole project, at least part of it. And then we have the extreme citizen science, which is a complete equal organization where there's no difference between if you're an expert or a volunteer. So in our case, since our projects were based on the volunteers got a basic training, and they also helped us to collect data either in field or digitally. And they also carried out simple interpretations in both cases. So I think our projects will end up in level 1, perhaps level 2 of this division. So a few words about the aims. Why did we want to do this? Here in Norway, we have a database, cultural heritage database, which is run by the Directorate for Cultural Heritage. The problem is that in that database is quite biased towards the cultural landscape and not the forested landscapes, what we have focused on in our projects. So the problem is that the cultural heritage database is significantly underrepresented in terms of forested areas. So that was a very important thing of reason to why we wanted to do this, because also the database is a backbone for both cultural heritage management, but also for cultural heritage for research on cultural heritage. So our aims was to improve the quality of the National Cultural Heritage Database as a basis for advanced management and for advanced research into people's use of forested areas and outfield areas. And of course, we also want to engage volunteers we saw that as a mutual benefit for all involved, for both the non-experts and for us as experts. I'll not go through these in detail, but just to give you an impression of what kinds of features we're talking about in the forest areas in the Trondheim region. It's very much about resource utilization. It's very much about charcoal production, tar production, iron production. We also find pitfalls for elk. And we also have other kinds of human impact on the landscape. As you see here, there can be house dwellings and also graves and transportation, in this case, shown by a hollow road. Yeah, and the first project, the project where we invited the Historical Society to help us to do the field verifications. We started up with an introduction to the project and a training of the people that signed up for this from the Historical Society. So we had first an indoor training, and then we went out to the field and showed people how these features looks in real life out there. And this we did every year because there was it was not necessarily the same people that wanted to help us with this. So I think it was good a way to cooperate, and we had good discussions in field, and I hope that I think that we also managed to raise interest for cultural heritage among members of the Historical Society. Yeah. What they were provided with was maps. They got orthophoto with all the interpretations that we have done beforehand. And they also got this LiDAR model images. So they got these two different maps to carry with them out in the field, together with forms where they could fill in information. And they also made measurements of the features they identified. So this was a quite low-tech, because, as you know, often people from historical societies often they are not young, to put it that way. So we deliberately wanted to do this as a low-tech project. But we also offered them to have a digital map that they could download on the mobile phones, and they were connected to GPS, so they could orient themselves by their mobile phones. And I think most of them did that in the end. Yeah. So we have so far covered these 5 areas in Klæbu, and the results, as you see here, we did 409 LiDAR identifications in these 5 areas, and through the field check, 80% of these were checked. It turned out that 85 of these were cultural features, while the rest was natural or modern features. And then we made a short prediction that shows that compared to what's in the cultural heritage database today, we can multiply this with at least factor 10. Then the other project, which was where volunteers helped us with interpret LiDAR data. We recruited people from a Facebook page called LiDAR in Norway, where we knew that there were both experts and non-experts that exchanged experiences with LiDAR. So we were sure that the people we involved or who volunteered to do this, they had some experience with looking at LiDAR data at least. And that was very, very good, because we didn't have time to give them any training, except they got some protocol they could read, and and from that understand how what we wanted them to do. So the only training was a few emails to and fro from if they had any questions, etc. We had the possibility to help them. Yeah. And then there also was provided with a collection of examples of how various cultural features looks on LiDAR images, in case they didn't know from before. And the result from this project, as you see, the volunteers, there were 5 or 6 volunteers who helped us for a few weeks, and they identified 1,340 anomalies. And then we archaeologists went out and did the field check, and we ended up with exactly the same detection success, 85% also in this case. So it was quite interesting. It was exactly the same. Yeah. And also here we did a prediction, which was even showed that there was even a much higher potential for finding cultural heritage features in forest areas in this project. So in the database today there's 406, but if we cover the whole municipality, we will end up with more than 11,000 features. So it's a substantial increase that we can show from this study. Yeah. So a few words to, I'm almost there now, about the lessons learned. It's obvious that the advantages of working with volunteers in this way is that you get a job done that is very difficult to do on your own because you have help from a lot of people. So you will get a lot of data that you can use in management or in research. So the really good thing here is to build that it's a good way to build bridge between academia and the general public using citizen science. The Norwegian Research Council, they have done a study and asked people engaged in citizen science about the experience with this, or if they have any concerns. And in that study, 2 main concerns came up. People were worried about the data quality, and people were also worried about how time-consuming is it to involve many volunteers. In terms of data quality, at least in these 2 studies, shows that with an identification success of 85%, which has been verified in field, is a quite good result. Of course, this was a very straightforward. It was not any rocket science. It's a very straightforward project. But anyhow, I think we don't have to worry very much about the data quality, because also the interpretations showed to be the right ones. Another thing is about the concern about time, how time-consuming it is. And of course, you need to invest the time in training people, and you can't underestimate the need for that, especially when we worked with a historical society. We used a lot of time to train them and go out into the field and work with them. But also it was a gain for us to have this communication with people. But the training part is quite time consuming. And also, you will also have to count, make your project take into account that you have to that there will be a need of continuous follow-up of people. Yeah. So it is, I would say, it is quite time consuming. But the conclusion is that even though it is resource demanding, it is still efficient and cost effective. And if I should point of one of these projects as the most cost effective, that will be the methodological model, because the people that were involved there was a bit more trained on their own because they had experience with LiDAR data, even though we didn't have the opportunity to do any training for them. It was still, I think, more, they were more independent and did the job without too much follow-up. And also to work with digital data, or people can sit in their homes and help us to interpret data. It's of course season and weather independent. You can do that whenever you have time for it. And also it's independent of residents. Obviously, when we worked with a historical society, it was people from the area, from Klarby municipality. While when we worked together with volunteers on the other project, we had people sitting in various places in Norway and even one in Denmark. So that's also a thing to take into account, that it's independent of residents. Yeah. So the conclusion is that the use of LiDAR data coupled with the involvement of volunteers has proven to be a viable solution for improving the quality and reliability of cultural heritage database as a basis for cultural heritage management and research. So the next step is to how do we implement this on a larger scale? Because I don't think I mentioned it, but the last project was financed by the Directorate for Cultural Heritage, who funded the project, and I had some meeting and presentations for them afterwards, and we are negotiating or discussing how to what will the next step be here, because the plan or the wish is to do this, offer this opportunity for people to help us to identify anomalies on digital LiDAR data. We want to do that and offer that for the whole country, as in theory, anyhow. But then it's of course a question of who should finance this and who should organize it and who should run this. So there's a lot of things that could be followed up, and so I think the most important outcome of these two projects is that we now have good experience and we can got answers sort of on a good deal of questions related to use of LiDAR and citizen science. These are not the first, of course, these are not unique, because there has been quite a few projects conducted especially in the UK, but also in the Netherlands. There have been projects where archaeologists have used LiDAR data and involved volunteers to help them with, like here, interpretation of LiDAR data or the field verifications. Yeah. So I think that was my word for today. I just have want to acknowledge some of my colleagues and other people that have been involved in the project, especially the Historical Society, the volunteers that helped us on the web interpretations, and a range of my good NTNU colleagues. Thank you.